Hello there, Year 9, and welcome to Lesson 5, the last lesson of Week 11. Today we're going to be looking at the response to exercise on the body. So last lesson we did about aerobic respiration. Today we're going to be looking at how it affects our body when exercising. So the first thing I want you to do from memory is try and write down the balanced symbol equation for aerobic respiration. Now, if you're struggling with that, then write down the word equation instead and see if you can get any of the symbols for any of the molecules underneath it. And then I would like you to suggest what happens to the body during a marathon. So if you are starting a marathon, what are the changes that happen in the body? So if you could pause the video and do that now, please. Okay, so hopefully you've had a go at those activities. So if you put the word equation for aerobic respiration, then you should have glucose plus oxygen makes carbon dioxide and water, and you might have put and energy as well. The balanced symbol equation will be C6H12O6 plus 6O2 makes 6CO2 plus 6H2O. For the suggesting what happens to the body during a marathon, perhaps you have spoken about if you do PE, build-up of lactic acid. You might have talked about breathing rate and heart rates increasing, and that's kind of what we're going to be focusing on in this lesson. So what we need to be able to do for this, so for 1 to 4, we need to be able to describe how the heart rate, breathing rate, and breath volume changes during exercise. We need to be able to explain why heart rate, breathing rate, and breath volume changes with exercise for 5 to 6s. And then above, we need to explain why stores of glycogen change with exercise. Okay, so here is the specification point that you might want to refer to. So if you want to have a read through this is from the AQA specification, things that they might examine you on. So you can pause the video and have a read of that. Okay, so last lesson we looked at aerobic respiration. We've got the equation here, and we know that it is an exothermic reaction because it transfers energy to the environment. What I'd like you to do now is go away and find the answers to these 3 questions. The last one is less of a question, but actually thinking about something you could do. So question number 1 is state why you need more glucose and oxygen for respiration when you exercise. That one should be pretty straightforward. The next one is describe what happens to the following when you exercise. So what is it that happens to your heart rate, your breathing rate, and glycogen levels? Now, if you haven't come across glycogen before, it is a molecule that is made up of glucose, and we store it in the body, kind of like how starch is stored in plants. We store glycogen. And the final thing that I'd like you to have a go at is design an experiment to test the fitness levels of your classmates. Include a method that your classmates could follow. So if any of you do PE as an option, you might be able to come up with something pretty straightforward. You would, I imagine, do fitness tests. But it's something that can be done in a room as opposed to in a gym or outside. So if you could pause the video or leave the video now and find out the answers or reply to those 3 tasks. Off you go. Okay. So for the first one, why you need more glucose and oxygen for respiration when you exercise, hopefully we found out that the muscles will be contracting harder and faster, and that requires energy. So the more they are contracting, the more energy they required, and they use glucose and oxygen in aerobic respiration to actually achieve that. Now, muscles will store glucose as glycogen, which can be converted into glucose during exercise. So even though there will be glucose in the blood, muscles will actually have a store of glycogen so that it can be accessed quickly for a prolonged period of time. So well done if you found that. For the next one, describe what happens to the following when you exercise. So we'll start with the heart rate. Now, hopefully you found that the heart rate increases. And that's because arteries supplying blood to the muscles dilate, so they get wider, so more blood can pass through it. Increased oxygen and glucose can then get to the muscles because cellular respiration is increasing, aerobic respiration is increasing, and also we need to remove that carbon dioxide from the muscles that's been made as well. So well done if you got the heart rate increases. Here are 4 points as to why that happens. So if you want to add that to your notes, then pause the video and do that. Okay, the next one was talking about breathing rate. So the breathing rate will obviously also increase. Why does that happen? Or how does that happen? Breathing is deeper, so more air can get into the lungs. So the volume of air increases. The volume of air that the lungs can take in increases. Red blood cells take up oxygen more quickly. The oxygen is carried to the muscles that are exercising, so they can get more oxygen to the muscles in order to respire. And also carbon dioxide is removed, so increasing the breathing gets rid of that carbon dioxide quicker as well. So well done if you got that the breathing rate increases. Below are 3 ways in which it does it, or why it does it. So you can add that to your notes as well. So pause the video and do that. Okay, the last one is glycogen. And you can see from the picture what glycogen looks like. Each one of those little molecules is a glucose molecule, and it's built up to make glycogen. And the glycogen stored in the muscles is converted into glucose, so the levels of glycogen will go down. The glucose gives the cells the fuel that they need for respiration. Respiration increases, so if you're exercising, more respiration is happening for the muscle contractions. That means more glucose is needed, so more of that glycogen is broken down. So pause the video and add, if necessary, how that happens, why that happens. Okay, so for designing an experiment to test the fitness levels of your classmates, including a method, there are lots of methods that you could give, but a good one for it is to measure the resting pulse rate. So you can place your middle finger of your right hand on your left wrist, for instance, and once you get the artery, you can obviously take a reading. If it's not a strong beat, then you can move your fingers slightly until you can clearly feel it. Now there is the reason why we don't use a thumb, for instance, on this, why we use the fingers, is the thumb has a stronger heartbeat that you can feel more than with the fingers, so we tend to use our fingers just so that it doesn't interrupt our results. Then we would use a stopwatch and we would count the number of beats per minute, and that is what is called the resting heart rate. So you would do this when the person is resting, such as sat down or lying down. That's going to be their resting heart rate. We would then stand for 1 minute, and then you can repeat the measurements on the pulse rate. And this is the standing heart rate, which will be different to the resting heart rate. Then time yourself whilst you carry out steady walking, for instance, on the spot for 3 minutes. At the end of the 3 minutes, count the number of beats, again for 1 minute. Then while sitting still, continue to take pulse rate readings, intervals of 1 minute until your pulse rate returns to the resting heart rate. So after we've done that moderate exercise, we can then find out how quickly it goes back to the resting heart rate. We can then try some vigorous activities, so something like jogging on the spot for 3 minutes, and then at the end of the 3 minutes, measure the pulse immediately, and then continue to take the pulse every minute until the pulse rate returns again to the resting rate. So we're looking at how quickly it returns back to that resting rate. Then we can record all the results in a table. So this is a method for how we could test the fitness levels of classmates. And fitness will often be indicated by how quickly that heart rate goes back to a resting heart rate. So this is a table that we can use for this experiment. And I'm actually going to ask you to put down this table and actually carry out that investigation. So if you copy down this table into your notes, or transfer over into a Word document or something like that, doesn't matter. And then I'd like you to carry out the investigation. So if you need to rewind this video a bit, or go back to that method, then please do so, and then you can see how to carry it out, and then you'll be able to complete the table. Now you'll notice that there are 3 columns for you to put data on. You are going to be repeating this, and then from that you can calculate your mean. So if you can get the table down, go back to the practical and carry it out, please. Okay, now obviously I'm not going to be able to take in everyone's data, but what you should find is that a normal resting heart rate is between 60 and 70 beats per minute. And then after some moderate exercise, so that was the walking, it'll go to about 80 or 90 beats per minute. And it will normally take about 5 minutes for it to go back to resting heart rates. After the vigorous exercise, so the jogging on the spot, it will probably be around 130 to 150 beats per minute. And it will normally take about 7 minutes for the pulse to return to normal. So you should be getting some results similar to that. Everyone, though, is different. So if you did not get those results, do not panic. Everyone has got different recovery times and different resting heart rates. Okay, so this is a very commonly used graph to show the effects of exercise on heart rate and breathing rate. So if we look at heart rate first, so going along the x-axis we have got time, and we've got 3 different sections. We've got at rest, during exercise, and then the recovery period. So we can see that at rest the line stays pretty much flat, and then when somebody is exercising, that will very quickly increase for the heart rate and the breathing rate. After exercise, when you've stopped and sat down or something like that, we then have this decrease in the heart rate and the breathing rate. That is going to be the recovery period, and then you can see that it levels off back to the resting heart rate. So can you sketch that graph, please, to show the effects of exercise on heart rate and breathing rate, and then you can annotate it with what is happening at each point. So pause the video and do that now, please. Okay, now as I said, everyone is slightly different. So this line is showing somebody who has got a lower resting heart rate, which then goes to the same pattern going up but lower, and then going back to the resting heart rate quicker. And that would be an example of somebody who would be fitter, who would have a lower resting heart rate. The heart rate and the breathing rate don't increase as much as the other person, the first person, and it recovers pretty well as well. So during exercise, the following things will happen. Your heart rate will increase, and we've looked at why that is, and that's to get more oxygen and glucose to those respiring cells. The breathing rate will also increase, and that is to get more oxygen into the blood and get rid of more carbon dioxide from the blood. We know that the arteries supplying the muscles will dilate, they get wider, so more blood can move around the body. And those three things all help muscles get the oxygen and the glucose that they need. So we've got three questions. Sorry, I've numbered the number 2 twice. That should be number 3. So we've got 3 straightforward questions just to review what it is that we have been speaking about. So question number 1, why should you use fingers of your hand and not your thumb to detect pulse in the wrist? Number 2, explain why 3 readings of the resting rate and the standing rate are taken. Number 3, explain why your heart rate increases more immediately after vigorous exercise than it does for moderate exercise. So you are going to have to think about the answers to those and try and link it into what we have covered. Deep thinking, why do you think there is variation in the resting heart rates of the members of the class? So why is it that everyone in year 9 will have slightly different results? So can you pause the video and answer those questions, please? Okay, so why should we use fingers instead of the thumb? Because the fingers on your hand do not have the pulse that your thumb would have, so it won't confuse the readings or interrupt the readings. Number 2, explain why 3 readings are used. This is the same for all of science, why we do multiples. That's because we can get a mean. So if there's any slightly different answers, then it will be averaged out. And then for 3, explain why your heart rate increases more immediately after vigorous exercise. The heart rate increases more immediately after vigorous exercise, excuse me, because more oxygen and more glucose has to get to the muscles because they are doing more work. And you could also say the more carbon dioxide needs to be removed. So well done if you have managed to answer those 3 questions. So using a different colour pen, tick off or amend if necessary. Okay, so the last question on there was, why do you think there's variation in the resting heart rates of members of the class? You could talk about anything. So you've got different sizes, different ages, different genders, different fitness levels is really important. All of those will affect your pulse rate. So if you manage to get a couple of those, or thought of all of them, or a lot of them, very well done. Okay, we're going to be finishing off now with just some whether statements are true on some data. We've got a graph here that's got the breathing rate on the y-axis, and then going along the x-axis we've got some different activities, so reading a book, walking along the beach, walking up the stairs, or running on a treadmill. So we'll go through each one and you can decide whether you think that statement is true or not. So breathing rate is faster when reading compared to walking. Is that true or is that false? Well done for being able to read that data if you said that it is false. So the breathing rate is faster when you're walking compared to reading. Number 2, walking along a beach is harder exercise than walking upstairs. Is that true or false? Again, that is false, because walking up the stairs has a higher bar that has got a higher breathing rate. Next question, the more intense the exercise, the greater the breathing rate. True or false? Well done if you said that that is true. So we can see that as the intensity of the exercise increases from reading a book to running on a treadmill, the bars are higher, so the breathing rate is higher. And the last question, breathing rate is not affected by the rate of exercise. True or false? Well done if you said false. it is affected, breathing rate is affected by the amount of exercise or the rate of exercise, because we can clearly see that the bars are different heights. So there is definitely an effect on the breathing rate. Okay, so that is it from me on this lesson on how our body responds to exercise. So hopefully we're able to describe how the heart rate, breathing rate, and breath volume changes with exercise. So all of them increase when we're exercising. Hopefully for 4 to 5s, we're able to explain why heart rate, breathing rate, and breath volume change with exercise. So the heart rate increases to pump more oxygen and glucose to the muscles. Breathing rate increases to take in more oxygen and get rid of more carbon dioxide, and the same for breath volume as well. And for 6 to 9s, explain why stores of glycogen change with the exercise. So glycogen stores will decrease because it's being converted back into glucose to go to those muscle cells that needed for respiration. So well done if you managed all of that. Well done for accessing this lesson as well. We're going to continue on with respiration next week for week 12. So very well done. Hope you're all well, and see you next time.